good morning. This is Kasturi De, and now I will discuss the electricity chapter question answer series. In my last two videos on this chapter question answer series, I discussed the objective type questions, and now we'll start with the short and long answer questions. Okay. Now, from where does electricity come to our homes? From city substations. What is an electric meter and where is it fixed in our house? It is a device. Electric meter is a device that measures the amount of electric energy consumed by a residence. How much electricity is consumed, how much electric energy is consumed by a residence, that is measured by a device, and that is known as electric meter. I mean, it can be residence, it can be business, or an electrically powered device. How much it is consumed by all these, that amount is measured by a device, and that is known as electric meter. It is usually mounted on the front or outside wall of the house. Okay, it is either on the front or outside wall of our house. Now state the purpose of kWh meter. It measures the amount of electric energy consumed by the consumer in the unit kWh. How much a consumer consumes this electric energy in his day-to-day life, that is measured by this kWh meter in the unit kWh, for which the electricity bill is paid to the electricity board, for which there's a bill generated by the electricity board, and that is paid by the consumer. Then for which you bill, it is kilowatt hour, that is kWh. Now, how can you check just by seeing the meter whether the electricity is in use or not? It is by seeing the armature. If it is moving, then we can say that the electricity is being consumed, the meter is on. Okay. Then following figures show the reading on the dials of the meter. State what is its reading. So please look at the picture very carefully. The first is the hand is between 2 and 3. In the second picture, it is between 8 and 7. The third picture is between 9 and 8. And the fourth picture is it between 8 and 9. Okay. So the bill will read as the meter reading will be first according to the first dial, it is 2, second is 7, third is 8, and the fourth is also 8. Okay, so the reading will be 2788. Okay. Now, one day the meter reading was 7643 units. What on the following day? Okay, on the following day, it was 7657. First was 7643 and the second one is 7657 units. What is the consumption of the electricity in a day? Consumption in a day is final reading minus initial reading. So final reading is 7657, initial reading is 7643, that is 14 units per day. Now, a source of potential difference V volt sends current to I ampere in a circuit for time t seconds. Write expressions for A, electricity and electrical energy supplied by the source, and B, electrical power spent by the source. So electric energy will be charge into potential difference, and electric energy or work done, that is charge into potential difference. So charge is given as Q, so that will be equal to IT. Okay, Q is equal to IT. IT means current into time. So you can say that W is equal to IT into V, or you can say VIT. So potential difference, that is given as V, and I is current is I. Okay, and T is time, T. Okay, T seconds. So P is equal to electrical energy is equal to VIT. Okay, joule. And the electric power that is spent on the source, that will be is equal to power is equal to W by T, that is work done by T, or electrical energy by in time T. So VIT, W, as I told you from the above formula, it is VIT and the time is T. So TT gets cut off, and so the P is equal to VI, potential difference into current. Next, name the unit in which you pay the cost of your electricity bill. How is it related to joule? We pay the electricity cost of electricity bill in a kilowatt hour. Okay, and how is it related to joule? 1 kilowatt is equal to 1 kilowatt. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Okay, that means 1 kilowatt is equal to 1000 watt and 1 hour is equal to 60 into 60 seconds. That gives us 3600000 joule. That is 3.6 into 10 to the power 6 joule. Now, what is an electric fuse? State its purpose in the household electric circuit. It is a safety device. Electric fuse, what is it? It is a safety device which is used to limit the current in an electric circuit, which melts and breaks the circuit whenever there is an excess flow of current through the circuit. That means when the current is flowing in the circuit and that becomes overloaded, okay, or more current is flowing through the circuit, that times what happened, the this electric fuse wire melts and breaks the circuit so that the current flow gets limited. Okay, that is overload is not there. Okay, and state its purpose in the household electric circuit. The purpose is to safeguard the circuit and the appliance connected to the circuit from being damaged. Okay, and if the current exceeds the limit of the fuse due to voltage fluctuations or short circuits, okay, if more current flows to the circuit due to voltage fluctuation or any short circuit, then what happens, this fuse that safeguards the circuit by limiting the current, or safeguard the appliance which is connected to the circuit by limiting the current flow. Okay, next is state one property of the material of a fuse wire. It melts at about 200 degrees centigrade. So the fuse wire should have a very low melting point so that can easily melt and break the circuit and protect the circuit from getting damaged rather. Can we use copper wire as a fuse wire? Give reason. Ordinary copper wire should not be used as fuse wire because the melting point of copper is higher and resistance is low, and so current can flow through it without melting the fuse wire or break the circuit, or it will not break the circuit, and it cannot be limited. The flow of the current will not be limited and it can cause a great damage to the circuit. Now, how does a fuse protect the electric wiring or an appliance from being damaged? The fuse breaks the circuit if a fault is the appliance causes too much current to flow. This protects the wiring and appliance, and if something goes wrong, and the fuse contains a piece of wire that melts easily. If the current goes through the fuse wire is too great, that is, it is overloaded, the wire heats up until it melts and breaks the circuit. Okay. Now, which fuse wire is thick? 5 ampere or 15 ampere? 15 ampere is thick, because the higher is the rating, the thicker will be the wire. Okay. Now, with what material lightning conductor is made up of? It is made up of copper. Okay, when a glass rod is rubbed with silk, why the glass rod and the silk gets charged? Because electrons get transferred from the glass rod to the silk, and that's why there is opposite charge which is being created in both this glass rod and the silk. Then, what is the full form of MCB? How is it superior to the fuse wire? MCB is known as miniature circuit breaker. Okay, please note the spellings: miniature circuit breaker. When there is excessive flow of current in the circuit, this MCB falls down and switches off the circuit quickly. Okay, it can be raised up after the fault being repaired, but in case of the fuse wire, it melts during overloading and needs replacement. Okay, so fuse wire melts and it has to be replaced, but in MCB what happens is the switch falls off and breaks the circuit, and once the fault is repaired, it can be again switched on. Okay, With which wire, live or neutral, is the fuse wire connected? It is connected to the live wire. Next, what do you mean by short circuiting of a circuit? If the insulation of the cable which is used in the wiring breaks, okay, the live wire comes in contact with the neutral wire. Okay, the live wire comes in contact with the neutral wire because the insulation in the cable has broken. Okay, this is known as short circuiting. Next is, following the figure shows two ways of connecting the three bulbs A, B and C to a battery. Name the two arrangements. Which of them do you prefer to use in the household circuit, and give reason to support your answer. See, from in the first figure, the A, B, C, they are connected one after the other. Okay, and in the B picture, they are just one below the other. Okay, so first connection is a series connection, and in the B picture, that is parallel connection. Now in the household, we prefer parallel connection. Why? Because if it is a series connection, if one bulb gets fused, okay, or it is removed, the other bulbs will not glow, because the circuit will not be a closed circuit. Okay, but in parallel connection, when it is switched on, but in parallel connection, the other bulbs will glow irrespective of whether the bulb goes wrong or if it is taken out. Okay, it's not involved with the other bulbs, because one of the any one of the bulb will be closing the circuit. Okay, so the parallel connection is preferred in the household circuit. Now state the voltage at which the electricity is supplied to our houses. It is 220 volts. Now state the color coding of the three wires in a cable used for wiring in a household electric circuit. For live wire, old one was red and new one it is brown. For neutral, old one was black and now it is light blue. For earth wire, both of them, old and new, both were either green or yellow. Now it is also green or yellow. Okay. Now next is, why is the metal covering of an electric appliance earth? It is because sometimes due to breaking of insulation of wire, live wires come in contact with the body of the appliance and we get a fatal shock. When the appliance is touched, we get a fatal shock because the live wire comes in contact with the body of the appliance. If the appliance is earthed, the current will pass to the earth and we will remain protected from an electric shock. Okay. Next is, what do you understand by electricity at rest? Electricity at rest, or static electricity we call it. That means when charges are not allowed to flow freely. They are static. These charges don't build up since there is no flow of electric charge. There's no flow of electric charge. That's why they are called static electricity or the electricity at rest. Okay. So, here I'll continue with the rest of the question answer in my next video. Please go through this. If you have any doubt, please write in the comment box. If you want to know any other questions beside this, please do write in the comment box. If you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And please do watch the full videos. Okay, you will understand the chapter much better. Okay, and do watch the text videos also for your reference, and go through the text videos very carefully. Okay, and please do subscribe to get the notification of my next video. Thank you for watching and have a good day.